We will do a few numerical examples related to the addition, subtraction, multiplication, and division of phasors. But let me explain the angle of the phasor quantity, which is measured with respect to x-axis. So this x-axis is known as a reference axis as well, because we measure the angle of the phasor with respect to x-axis. We can measure this angle in the counterclockwise direction as well as in the clockwise direction. You see, if we measure this angle in the counterclockwise direction, this angle is represented by theta, and this angle is positive. And if we measure the angle of the same phasor with respect to x-axis in the clockwise direction, this angle will be negative. Let us represent this angle by alpha, so this angle will be negative. So the angle in the counterclockwise direction is positive, and the angle in the clockwise direction is negative. Let us do a few numerical examples. We do example number 2.8. Example number 2.8 says, convert the following phasor into trigonometric, exponential, and polar form. The phasor is given over here, and this phasor is in rectangular form. So we have been given Z1 in rectangular form, and we need to convert it into trigonometric form, exponential form, and polar form. In order to convert this phasor from the rectangular form into the trigonometric, exponential, and polar form, we need to compute the impedance of this phasor, and we need to compute the angle of this phasor. So let us compute the magnitude of this phasor and the angle of this phasor quantity. So we calculate the magnitude of this phasor. The magnitude of this phasor will be equal to under root square of the real component, that is 3 square, plus square of the imaginary component, that is 4 square. So we get under root 25, and under root 25 is equal to 5. So the magnitude of this phasor quantity turns out to be 5. Let us calculate the angle of this phasor. So the angle of this phasor is equal to tangent inverse 4 by 3, and that is 53.1. So as the magnitude as well as the angle of this phasor are known, we can represent this phasor in trigonometric form. So in trigonometric form of representation, this phasor will be equal to 5 into cos of 53.1 plus j sine 53.1. The same phasor in exponential form of representation will be equal to 5 into e raised to power j 53.1. The magnitude of this phasor is 5, and the angle of this phasor is 53.1. We can represent the same phasor in polar form the magnitude of this phasor is 5 and the angle of this phasor is 53.1. So we have converted the phasor from rectangular form into trigonometric, exponential, and polar form. Let us do another simple numerical example. We do example number 2.9, and you guys can read these examples from my personal book. Convert the following phasor into rectangular form. So we have been given a phasor in polar form. The magnitude of the phasor is 10 and the angle of the phasor is 36.8. So this phasor is in polar form. We want to convert this phasor from polar form into rectangular form. So if you want to convert it into rectangular form, we need to find out the real component as well as the imaginary component of this phasor. So the real component of this phasor, which is represented by A, will be equal to the magnitude of this phasor, which is 10, into cos of the angle of the phasor, and the angle of the phasor is 36.8. So the real component will be equal to 10 into cos of 36.8. So the real component is 8. Let us compute the imaginary component of the phasor. The imaginary component of the phasor is represented by B, which will be equal to the magnitude of the phasor into sine of the angle of the phasor. And the magnitude of the phasor is 10 and the angle is 36.8. So the imaginary component of this phasor turns out to be 6. So the same phasor in rectangular form will be equal to Z, and Z will be equal to 8 plus J6. The real component of this phasor is 8 and the imaginary component of this phasor is 6. So we have converted a phasor from polar form into rectangular form in this numerical example. You guys can do it with the help of these equations, and you guys can do it directly with the help of your scientific calculators. So using your scientific calculators, you guys can convert a phasor directly from rectangular form into polar form and from polar form into rectangular form. So please consult your senior colleagues and learn how to convert a phasor from rectangular into polar form and polar to rectangular form. This is very important. So let us do example number 2.10. In example number 2.10, we are going to add the following two phasors. Z1 is in polar form of representation. The magnitude of Z1 is 10 and the angle of Z1 is 36.8 degree. Z2 is in polar form as well. The magnitude of this phasor is 5. The angle of this phasor is 53.1. So we know that we cannot add two or more than two phasors in polar form. In order to add these two phasors, we need to convert them into rectangular form for the sake of addition as well as subtraction. As we want to add these two phasors, so we want to convert them into rectangular form. So let us convert Z1 into rectangular form and let us convert Z2 into rectangular form. So we convert Z1 into rectangular form. The real component of Z1 is 8. The imaginary component of Z1 is 6. You guys can do it with the help of calculators. If you guys want to do it with the help of equations, so let me review the equations. A will be equal to 10 into cos of 36.8, and 10 into cos of 36.8 is equal to 8. Let me check the angle of Z1. Let me confirm the angle of Z1. Yes, it is 36.8. So this is how you calculate the real component of A, and the imaginary component of A will be equal to 10 into sine of 36.8, and this is 10, so let me make it 10. Okay, so 10 into sine of 36.8 will give you 6. So we have converted this phasor Z1 to rectangular form. Let us convert Z2 into polar form. If you guys want to convert Z2 into polar form, the real component will be equal to 5 into cos of 53.1, and cos of 53.1 results in 3. This is how we calculate the real component of Z2. If you guys want to compute the imaginary component of Z2, it will be equal to 5 into sine of 53.1, so that will be equal to 4. So you guys can calculate the real and the imaginary component of Z2 with the help of these equations, and you guys can directly convert the polar form of Z1 and the polar form of Z2 directly to rectangular forms with the help of your scientific calculators. So you need to know how to convert the rectangular form into polar form and the polar form into rectangular form with the help of your calculators. As these two phasors are in rectangular form, we can add these two phasors. And we know that the addition of two phasors results in a new phasor. The resultant phasor is represented by ZA, which is equal to Z1 plus Z2. So the real component of ZA will be equal to 8 plus 3, and the imaginary component of ZA will be equal to 6 plus 4. So ZA will be equal to 11 plus J10. This is the resultant phasor, and the resultant phasor is in rectangular form. Well, if you want to convert this resultant phasor into polar form, we can do it directly with the help of our scientific calculators, or we can do it with the help of these equations as well. We know that the magnitude of the resultant phasor will be equal to under root square of the real component. So here is the square of 11, that is 121, plus square of the imaginary component. So here is the square of 10, which is 100. So the magnitude of the resultant phasor is 14.86. We can calculate the angle of the resultant phasor with the help of this particular equation. Tangent inverse 10 by 11 will give you 42.27 degree. So the same phasor in polar form will be equal to 14.86. This is the magnitude of the resultant phasor, and 42.27 degree is the angle of the resultant phasor. So we convert the phasors from polar form into rectangular form with the help of our scientific calculators, or we can convert it with the help of the equations which we have studied in the theoretical class, right? Subtract Z2 from Z1. This is another numerical examples. So in this numerical example, we want to subtract Z2 from Z1. Z1 is in polar form and Z2 is in polar form. We know that if you want to subtract one phasor from another phasor, the subtraction of one phasor from another phasor results in a new phasor. And we can subtract one phasor from another phasor in rectangular form. We cannot subtract one phasor from another phasor in polar form of representation. So we need to convert these two phasors into rectangular form for the sake of subtraction. So let us convert them to the rectangular forms. We have already converted these two phasors into rectangular form. Z1 is equal to 8 plus J6 and Z2 is equal to 3 plus J6. You guys can convert these phasors from polar form into rectangular form with the help of equations, or you guys can do it directly with the help of your scientific calculators. So let us subtract Z2 from Z1. The subtraction of Z2 from Z1 results in a new phasor. So Zs will be equal to 8 minus 3. This is the real component of the resultant phasor, plus J, 6 minus 4, and 6 minus 4 is the imaginary component of the resultant phasor. So the resultant phasor in rectangular form of representation is equal to 5 plus J2. The real component of the resultant phasor is 5, and the imaginary component of the resultant phasor is 2. We can convert this phasor from rectangular form into polar form either with the help of equations or with the help of our calculators. So if you want to convert the resultant phasor into polar form, we need to calculate the magnitude of this phasor. And the magnitude of this phasor will be equal to under root square of the real component. This is the square of 5, which is 25, plus the square of the imaginary component. This is the square of 4. This is the square of 2, which is 4. So the magnitude of the resultant vector is 5.38. Let us compute the angle of the resultant phasor. So the angle of the resultant phasor will be equal to tangent inverse 2 by 5. 2 is the imaginary component of the resultant phasor, and 5 is the real component of the imaginary phasor. So the angle of the resultant phasor is 21.8 degree. So the same resultant phasor in polar form of representation is equal to 5.38, which is the magnitude of this phasor, and the angle of this phasor is 21.8 degree. Well, this is example number 2.12. Multiply Z2 and Z1. So we have been given two phasors in polar form of representation. We know that we can multiply phasors in rectangular form, but if we want to multiply these phasors in rectangular form, it will take a lot of time. So the multiplication in rectangular form of representation is a time-consuming technique. It is a time-consuming method. It is a time-consuming process. So the multiplication in the polar form is very simple, especially if we have more than two phasors. So we are going to multiply these two phasors in polar form. So the magnitude of the resultant phasor will be equal to the magnitude of Z1 multiplied by the magnitude of Z2, and the magnitude of Z1 is 10, while the magnitude of Z2 is 5. So the magnitude of the resultant vector is 50. So the magnitude of the resultant vector is 50. The angle of the resultant vector is equal to theta 1 plus theta 2. So here is theta 1, here is theta 2. The addition of these two angles gives you 89.9 degree. So the resultant phasor in polar form is equal to the right hand side. 50 is the magnitude of this phasor, and 89.9 degree is the angle of the resultant phasor. So it is very simple and convenient to multiply two or more than two phasors in polar form. For the magnitude of the resultant phasor, you guys need to multiply the magnitudes of these phasors. For the angle of the resultant phasor, you guys need to add the angles of the given phasors. So let us do another numerical example. This is example number 13, which says that divide Z1 by Z2. So Z1 is in polar form of representation. Z2 is in polar form of representation as well. We know that we can divide one phasor by another phasor in rectangular form as well. But this division will take a lot of time if the phasors are in rectangular form. So it is very convenient to divide one phasor by another phasor in polar form. So we are going to divide Z1 by Z2 in polar form. The division of Z1 by Z2 results in a new phasor. This new phasor is represented by ZD. So here is Z1. We know that Z1 is in polar form. So the magnitude of Z1 is 10. The angle of Z1 is 36.8 degree. Here is Z2. The magnitude of Z2 is 5. And the angle of Z2 is 53.1. So for the magnitude of the resultant phasor, we divide the magnitude of Z1 by the magnitude of Z2, which is 2. So the resultant, the magnitude of the resultant phasor is 2. And in order to compute the angle of the resultant phasor, we shift this angle to the numerator. The sign of this angle will change. So we have 36.8 minus 53.1, and this will give you an angle of minus 16 point. It will give you an angle of minus 16.8 degree. So the magnitude of the resultant phasor is 2, and the angle of the resultant phasor is minus 16.8. This is how we do the relevant numerical example. Inshallah, we shall start the generation of the AC voltage in the upcoming class. So we will talk about the generation of the AC voltage in the upcoming class. And we will consider a very simple generator for the generation of the AC voltage, and we will talk about some fundamental quantities of the AC voltage. We will define the time period of the AC voltage. We will define the frequency of the AC voltage. We will define the peak or the maximum value of the AC voltage. We will define the time varying voltage, the time varying equation for the AC voltage, and we will consider the waveform of the AC voltage in the upcoming class. Thank you so much. I shall see you in the upcoming class.